You are listening to The Vocal Technologist. Spoken tech for your ears.
Welcome back. You're listening to Vocal Technologist, and today we're trying to cut through some of the noise in development. We want to pull out the really impactful stuff, the insights that might actually surprise you. Think of it as your shortcut to knowing what's genuinely moving the needle. Okay, let's get into it.
Yeah, and what's fascinating here is how many common assumptions we're probably going to challenge today. We'll look at code optimization myths, building reliable AI agents, and even like what does valuable engineering work really mean? It's all about practical takeaways.
Absolutely. Let's kick off with something I know trips up a lot of developers, myself included, sometimes use callback and useMemo and React. You hear so much about using these for optimization, but there's this feeling they often add complexity without real gains. It seems backwards.
It totally is counterintuitive. The thing is, these hooks, they have really specific kind of narrow use cases. Developers often reach for them thinking, performance boost, but they forget about the overhead involved. Like you see it a lot when passing props to components that aren't memoized themselves, or maybe using props directly as dependencies in useCallback or useEffect. There was a great example from the Sentry code base, actually. It showed how values you think are memoized can still get invalidated because, well, their dependencies aren't memoized.
Okay, so you're doing the work.
Exactly. You add the cost of memoization, maybe the complexity, but you don't get the actual performance benefit. It's just busy work.
Right, that Sentry example really paints a picture. Like meticulously setting up dominoes, but forgetting to push the first one. You did the work, but nothing happens.
Yeah.
It shows how easy it is to fall into these, let's call them optimization traps. And speaking of, building efficient and engaging UIs, there's another tool that maybe doesn't get enough credit for its dynamic power. SVG, Scalable Vector Graphics. People see scalable image, but are they missing the boat on performance and interactivity? This is where it gets really interesting.
Oh, totally. The real magic of SVG isn't just that it scales infinitely, which is amazing for responsive design, obviously. It's that because it's XML-based, its parts, its primitives, like circles, rectangles, they aren't static pixels, they're dynamic.
Dynamic how?
Well, you can style and animate pretty much any attribute directly with CSS and JavaScript. Think about stroke or fill. You can change them on the fly. You can do those cool drawing effects using stroke and stroke-dashoffset manipulations. Raster images just can't do that efficiently.
Oh.
And crucially, there's the viewBox attribute. This sets up an internal coordinate system. That's what ensures SVGs scale perfectly and stay responsive, solving all those annoying fixed positioning problems you might hit otherwise. It's incredibly powerful for interactive interfaces.
That's a fantastic point. So much potential packed into what looks like a simple format. And this idea of dynamic, responsive systems, it feels like it leads right into the next big thing, building production-ready AI agents. This AI evolution is not just changing how we build, is it? It feels like it's fundamentally making us question what valuable engineering work even is. Like, what does focus time really mean for an engineer today when AI might be doing more of the routine coding?
Yeah. That's a huge question, and building these AI agents reliably, it's methodical work. We're seeing like 6 key principles emerge. First, you need really clear, detailed system prompts. Any ambiguity there, that's asking for unpredictable behavior.
Okay.
Then strategic context management. You can't just flood the model with information. It gets overwhelmed, less accurate, or slower.
Right, keep it focused.
Exactly. And you need carefully designed tools for the AI to use. Simple interfaces are key, plus robust feedback loops, maybe using domain-specific validation, and using LLMs themselves for error analysis. That's super helpful for spotting blind spots or debugging tricky failures that are hard for us humans to track down.
It definitely sounds like building with AI requires a different kind of meticulous design. So back to that bigger question then. Does focus time for an engineer always mean just sitting alone, headphones on, coding?
Well, if we connect this to the bigger picture, I'd say it absolutely challenges that traditional view,
Right.
The idea that an engineer's main job is just writing code. Code is vital, obviously, but creating real impact, delivering value that often happens outside the IDE, your code editor. Think about those crucial design meetings, writing clear documentation that saves your whole team hours down the line, or even just helping a teammate get unstuck.
Yeah, that stuff adds up.
Massively.
Yeah.
That kind of work can be just as, if not more valuable. It really broadens our definition of what an engineer's impact truly is.
So wrapping this up for today, what does all this mean for you listening? We've gone from, the nitty-gritty of React hooks to the power of SVG, building AI agents, and even rethinking what our daily work as engineers looks like.
Yeah, it raises an important point, I think. Being an effective developer now, it's not just about technical skill, right? It's also having a critical eye for the tools you use, seeing your contribution more holistically within the team, and having a really thoughtful approach to new tech like AI.
Well said.
Huh.
So maybe as you go into your work this week, think about this. Are your most valuable contributions always happening where you expect, in that focused coding time? Or could there be some untapped impact waiting for you just outside that usual focus zone? Something to think about. Thanks for joining us today.
Spoken Tech for your ears.